Hello students, welcome back to Future Foundation. Students, in last class of straight lines, we did questions based on normal form. In today's class, we will learn the concept of angle between two lines and then we will discuss questions related to this concept. So let's start the class. Angle between two lines. So let us draw first two lines which are intersecting at some angle, say theta. Say line L1 is inclined at an angle alpha with the positive direction of x-axis, and line L2 is inclined at an angle beta with positive direction of x-axis. So from figure I can say theta plus alpha is equal to beta, or theta is equal to beta minus alpha. Okay, if I take tan both sides, then it will become tan theta is equal to tan of beta minus alpha. On right hand side I can expand by using tan a minus b. So this will become tan beta minus tan alpha on 1 plus tan alpha into tan beta. Right? Now here tan beta and tan alpha are the slopes of L1 and L2 respectively. Say slope of L1 is m1 and slope of L2 is m2. Or you can say m1 is equal to tan alpha, m1 is equal to tan alpha, and m2 is equal to tan beta. So here m2 minus m1 upon 1 plus m1 m2, which is tan theta. And from figure I can say m2 is greater than m1. So also if m1 m2 is greater than m1 implies tan theta is positive. Tan theta is positive implies theta is acute, right? Okay, so here theta will be tan inverse of m2 minus m1 upon 1 plus m1 m2. So now this is theta in general, tan inverse of m2 minus m1 upon 1 plus m1 m2. But when we are asked to find the angle between two lines, then we consider acute angle only unless it is stated. Okay, so make note for this. Note 1. If angle is asked between lines, two lines, consider it acute unless is stated. Okay, also note 2. When two lines intersect, there are two angles. One is acute and one is obtuse. So in figure this, if this theta is acute, then this is also the angle between same lines, say phi, then it is obtuse. So I can say phi is equal to pi minus theta, which is obtuse, okay, or in this figure also phi. right? So always there are two angles when two lines intersect. Theta in general, when we are asked to find between two lines, so theta is tan inverse mod of m1 minus m2 upon 1 plus m1 m2. Okay. Now note 3. Note 3 is if L1 E1x plus B1y plus C1 is equal to 0 and L2 E2x plus B2y plus C2 is equal to 0. Here lines are given in general form. So slope of line L1 is minus times coefficient of x upon coefficient of y. So m1 is minus a1 upon b1 and m2 is minus a2 upon b2. Now tan theta will become m1 minus m2 upon 1 plus m1 m2, that is minus a2 upon b2 plus a1 upon b1 upon 1 plus a1 upon b1 into a2 upon b2, right? So this will be a1 b2 minus b1 a2 on a1 a2 plus b1 b2. This is tan theta. Note 4. If lines are parallel. Lines are parallel implies theta is equal to 0 degree. Okay, like this. So theta is 0 implies tan theta is 0. Theta is 0 degree implies tan theta is 0. Implies m1 minus m2 upon 1 plus m1 m2 is equal to 0, or m1 minus m2 is equal to 0, or m1 is equal to m2. Okay, means if lines are parallel then slopes are equal. Also, if lines are perpendicular implies theta is equal to 90 degree, implies tan theta is tends to infinity, implies cot theta is equal to 0, implies 1 plus m1 m2 upon m1 minus m2 is equal to 0, implies m1 m2 is equal to minus 1. Okay. Means if lines are perpendicular then m1 m2 is equal to minus 1 in general. Okay, what why I said in general, this thing will be clear by taking an example. First, write generally if lines are perpendicular then m1 m2 is equal to minus 1, but not always, right? It is not always true that if lines are perpendicular then m1 m2 is equal to minus 1, as in example or in figure which I am going to draw. There are two lines, this and this. These are perpendicular. One is parallel to x-axis and one is parallel to y-axis. And one is parallel to y-axis, so it is having slope as infinity, and one which is parallel to x-axis having slope as 0. So here m1 m2 is not equal to -1. m1 m2 is not equal to -1, right? But this is the only case. Okay, this is the only case. But in general, if m1 m2 is equal to -1, then lines are perpendicular. But if m1 m2 is equal to -1, implies lines are perpendicular. Perpendicular always. So what I said in the above statements, if m1 m2 is equal to -1, then lines are perpendicular always. But if lines are perpendicular, then m1 m2 is equal to -1 is not always true. Okay, but in general we take, if lines are perpendicular, then m1 m2 is equal to -1. But keep in mind, if you are given a question of assertion reason, है ना, say in one statement it is written that if lines are perpendicular, then m1 m2 is equal to -1. Is it true always? Then you have to then you have to take then you have to say no, it is not always the case. Okay, now come to the question. Find angle between √3x minus y plus 1 is equal to 0 and x minus y plus 2 is equal to 0. Here m1 is minus times coefficient of x upon coefficient of y, which is √3, and m2 is minus times coefficient of x upon coefficient of y, which is 1. So from tan theta is equal to m1 minus m2 upon 1 plus m1 m2, and we have to take mod always, because we are considering acute angle only. So this is √3 minus 1 upon 1 plus √3, as it is positive inside, so I can remove mod. So this is √3 minus 1 upon √3 plus 1, just tan theta, and √3 minus 1 upon √3 plus 1 is nothing but tan 15. So theta is 15 degree. Or someone can say, sir, theta can be 180 plus 15, which is 195, but you know very well that angle between two lines lies between 0 and 180 degree open. Okay, तो यहाँ पे इस बात को मेंशन कर लेते हैं, थीटा lies between 0 closed and 180 open. Okay, yeah, so let's move to next question. If lines p times p square plus 1 x minus y plus 9 is equal to 0, and p square plus 1 square x plus p square plus 1 times y plus 29 is equal to 0, are perpendicular to the same line, find p. Okay, so here m1 is equal to minus times coefficient of x upon coefficient of y, which is p times p square plus 1. Okay, and m2 is minus times p square plus 1 whole square upon p square plus 1, which is minus of p square plus 1. Right, now also these two lines are perpendicular to the same line, means condition is like this, situation is like this. This is L1, this is L2, and these both are perpendicular to the same line. So from figure I can say L1 and L2 are parallel, implies M1 is equal to M2, implies P times P square plus 1 is equal to minus of P square plus 1, implies P times P square plus 1 plus P square plus 1 is equal to 0, means P square plus 1 common, P plus 1 is equal to 0. As P square plus 1 cannot be 0, so P plus 1 is equal to 0 implies P is equal to minus 1. Okay, let's come to next question. If lines 2x plus a square y plus 2 is equal to 0 and x plus a minus 1y minus 1 is equal to 0 are perpendicular, then a is equal to question mark. So first of all, I will find m1 and m2. So m1 is minus 2 upon a square by using the concept slope of line minus times coefficient of x upon coefficient of y. So m1 is this and m2 is equal to minus 1 upon a minus 1, right? Now according to question, m1 m2 is equal to minus 1. If lines are perpendicular, then in general m1 m2 is equal to minus 1 I can take. So minus 2 upon a square to minus 1 upon a minus 1 is equal to minus 1. Okay, so this will be a square times a minus 1 is equal to minus 2, or a square minus a plus 2 is equal to 0. From here I can say one factor is a plus 1 and other factor is a square minus 2a plus 2 is equal to 0. So quadratic factor has discriminant as negative, so this will not give any real root for a, so a is equal to minus 1, which is the required answer. Now again note continued. Fifth note is line parallel to given line. In this we will write, let given line be ax plus by plus c is equal to 0. Line parallel to ax plus by plus c is ax plus by plus k is equal to 0, and this k can be found out by using condition in the question. Okay, for example, question is find line parallel to the line x minus 2y plus 5 is equal to 0 and passing through 1 comma 2. Okay, so here it is a line x minus 2y plus 5 is equal to 0 through which a line is parallel which is passing through 1 comma 2. So let equation of line be x minus 2y plus k is equal to 0. Okay, and also it is passing through 1 comma 2, so I can put 1 and 2 in place of x and y. So 1 minus 2 into 2 plus k is equal to 0 implies k is equal to 3. So finally equation of line will become x minus 2y plus 3 is equal to 0, which is required equation. Next question is find equation of line parallel to 3x plus 4y plus 4 is equal to 0, making a triangle of 24 square units area with coordinate axis. Right? What is given in the question? In question, it is given that a line which is making a triangle with coordinate axis and parallel to the given line, say this is 3x plus 4y plus 4 is equal to 0, right? So a line parallel to 3x plus 4y plus 4 is equal to 0 and making a triangle with coordinate axis of 24 square units area. So let equation of line be 3x plus 4y plus k is equal to 0. Okay. Also delta is what? 24 square units. So delta is nothing but half base into height. So half base. Base is this x-intercept, which is minus k by 3. Minus k by 3. I'm using mod because length is always positive. And height is y-intercept. And y-intercept is minus k by 4. So again mod of minus k by 4 is equal to 24. So from here k square is equal to 24 into 24. K square is equal to 3 4 is 12, 2 is 24 to 24 means k is equal to plus minus 24. So equation of lines, there are two possible lines which are 3x plus 4y plus 24 is equal to 0, or second one is 3x plus 4y minus 24 is equal to 0. Okay, line perpendicular to the given line, line perpendicular to the given line. Let given line be ax plus by plus c is equal to 0. Line perpendicular to ax plus by plus c is equal to 0 is bx minus ay plus k is equal to 0. So see here, if line is perpendicular, then we have to interchange coefficients of x and y and sign of one coefficient and constant term. But in case of parallel lines, coefficient of x and y remains same, but we have to change constant term. Okay, and here also this k can be found by using some extra condition given in question. Condition given in the question, right? Take an example. Question is find equation of line perpendicular to 3x plus 4y plus 7 is equal to 0 and passing through 1 comma 2. Okay, so equation of line consider equation of line be 4x minus 3y plus k is equal to 0, right? And also it is passing through 1 comma 2, so I can place 1 and 2 in place of x and y. So 4 into 1 minus 3 into 2 plus k is equal to 0, so k is equal to 2. Therefore equation of line be 4x minus 3y plus 2 is equal to 0. Let us take one more question. Question is line 2x plus 3y is equal to 7 intersects coordinate axes at A and B. Find perpendicular bisector of segment AB. So this 2x plus 3y is equal to 7. This here x-intercept is 7 by 2 and y-intercept is 7 by 3. And what we have to do in question, it is given that line 2x plus 3y is equal to 7 intersect coordinate axes at A and B. So A is this and B is this. Find perpendicular bisector of segment AB. So perpendicular bisector is nothing but a line passing through the midpoint of segment AB and is perpendicular also, right? So equation of perpendicular bisector of line or perpendicular bisector B 3x minus 2y plus k is equal to 0, right? And also it is passing through the midpoint of AB, and the midpoint of AB, say this is C, so coordinate of C is 7, coordinates of C are 7 by 4 comma 7 by 6, so 3 into 7 by 4 minus 2 into 7 by 6 plus k is equal to 0. Okay, so 2 3 just 6, same is 12, so this is 63 minus 28 plus k is equal to 0, so k is equal to minus 35 by 12. right? So equation of perpendicular bisector of AB is 3x minus 2y is equal to 35 by 12, or 36x minus 24y minus 35 is equal to 0. So students, let's meet in next class. Till then, bye bye and take care.